In this video, we will talk about how to solve exponential equations. So let's work through a few examples. Let's say we have 2 to the power of x is equal to 7. How can we solve for x? Well, one trick that we can use when we have this type of equation is we can rewrite it as log of both sides. So we can say the log of 2 to the x is equal to the log of 7. Now, once we have it in this form, another trick that we can use is we can rewrite the x out front. So whenever we have a log of some number raised to a power, that power can be rewritten in front of the log. So we can actually rewrite this as x times the log of 2 is equal to the log of 7. And now to solve for x, we just need to divide both sides by the log of 2. So the log of 2 will cancel out on this side, and we'll be left with x is equal to log 7 over log 2. So this is our exact answer. If we were to punch this into a calculator, we would get something like 2.80735 and a bunch of other numbers. But that is what x will be equal to. And we can verify that our answer is correct by plugging this into our original equation. So if we did 2 to the power of 2.80735. For example, if we punch that into a calculator, we would get something like 6.99999 repeating, which is basically 7. And if we typed in if we expanded even more decimals out here and we did 2 to that number, it would be about 7. But that's how we can kind of double check ourselves. Let's try another example. Let's say we have 3 to the power of x plus 2 is equal to 7. How can we solve for x? Well, we'll use the same trick where we can first rewrite this as the log of 3 to the x plus 2 is equal to the log of 7. And remember, when we said we had a log of some number raised to a power, we can rewrite this whole power out front. So we can actually rewrite it as x plus 2 times the log of 3 is equal to log of 7. All right, so to get x all by itself, we can divide both sides by log of 3. So on the left-hand side, we're left with x plus 2 is equal to, and over here we have log 7 divided by log 3. So the last step to get x all by itself is to subtract a 2 from each side. So our final answer is x is equal to log of 7 divided by log of 3 minus 2. So that's the exact answer. If we were to punch in log of 7 over log of 3 into a calculator, we would get something like 1.77124 and a bunch of other numbers. And then if we did minus 2, our final answer would be something like negative 0.228756 and a bunch of numbers after that. So that is what x will be equal to. And once again, we can verify that that's correct by plugging it into our x of our original equation. So if we did 3 to the power of negative 0.228756 plus 2, we would get something like 6.9999. So something very close to 7 to verify that we got the correct answer. All right, let's try one more example. Let's say we have 16 to the power of 4x minus 5 is equal to 8 to the power of 2x plus 10. So how can we solve for x? Well, one trick that we can use is we can try to make it so that these two numbers have the same base. So we can write 16, we can recognize that that is 2 to the 4th power. So 2 times 2 times 2 times 2, that's equal to 16. So we could rewrite 16 as 2 to the 4th. And then we have that whole thing raised to 4x minus 5. On this right-hand side, we can recognize that 8 is 2 to the 3rd power. So we can rewrite that as 2 to the 3rd to the power of 2x plus 10. Okay, now after we've rewritten it, we can recognize that this 4, we can actually just distribute it into the exponent to multiply these values to get a new exponent. So what we really have is 2 to the 4 times 4x, that's 16x. And 4 times negative 5, that's negative 20, is equal to, over here we can distribute that 3 to each of these terms. So we'll get 2, 3 times 2x, that's 6x, and 3 times 10, that's plus 30. Okay, so now that these, both the left-hand and right-hand side are 2 to the power of something, it means that these exponents must be equal. So what we can do is just set them equal to each other. So we can say 16x minus 20 is equal to 6x plus 30. And we can just solve for x. So let's say we add a 20 to each side. Plus 20 plus 20. On the left-hand side, we're left with 16x is equal to, on the right-hand side, we have 6x. 30 plus 20, that's 50, so plus 50. And then we can subtract a 6x from each side to get all of the x's on the same side. So 16x minus 6x, that's 10x. And over here, we're just left with a 50. So to solve for x, we can divide both sides by 10. And x is equal to 5. So that is our final answer. And what we'll find is if we want to double check our work, if we plug in a 5 in for x in this original expression, over here we'll get 16 to the power of 4 times 5 minus 5. So that would be 16 to the power of 4 times 5 is 20, minus 5 is 15, so 16 to the 15th power. And then over here, if we plug in a 5 for x, we'll get 8 to the power of 2 times 5 plus 10. So that is 8. 2 times 5 is 10, plus 10 is 20. 8 to the 20. And what we'll find is this number will be massive, but if we punch it into a calculator or some software, 16 to the 15th power will be equal to 8 to the 20th power. So that's how we can double check that we got the right answer for x. Thanks for watching.